All right, welcome back. Now, in this K-means classroom class, we are actually going to consider what K-means means and why we need K-means and at what circumstance do we use K-means and how do we use it. And after we get an intuition about what K-means means, we go to the whiteboard to get an intuition. We also see some demonstrations of this K-means, and then after that, we will go to the lab and then have a practical implementation of that. All right, so we will first see the concept behind that. We also see some visual representations of K-means. Then we will go to the lab and see the implementation of that. All right, so let's get started and then see what K-means is all about. All right, so let's go to the whiteboard and then start getting an intuition about what K-means classroom means. Okay, so over here, if you remember when we are talking about the connectivity base, right? When we're talking about the connectivity base, right? When we're talking about the connectivity base classroom, we say that items that are closer to each other, right? Items that are closer to each other, they are actually similar to each other. So if you remember, we were having point A and then point B, and then we were also having point E and then point F, then point C somewhere here, and then we're having some point D over here. So we said that these items are closer to each other, so we connected them together, right? And then we said, okay, this one is closer to that, so we connected them. And then we said that this one is also closer to them. And then finally, we connected everything together, okay? So this is actually what the connectivity was trying to tell us. Now, it's actually saying that items that are closer, right? Items that are closer to each other, right? Closer to each other. This is basically what the connectivity is trying to tell us. Items that are closer to each other are also similar to each other, right? They are similar, right? They are similar to each other. All right, so that is basically what the connectivity helped us to actually do. Okay, so let's consider what the K-means classroom will actually help us to do over here, right? So let me actually do it this way. So we have the K-means, right? Let's consider what the K-means classroom, right, will actually help us to do over here. So let's understand what K-means means. So what K-means will actually help us to do is to actually associate certain points according to the centroid that we have, right? So let's try and then let's say we have this, right? Let's say we have several points in here, right? So let me try and then populate some points in here, right? So let's say we have these points. Okay, let's say we have these points in here. Now, what K-means will actually help us to do is to associate a centroid. So let's say we have these central points, right? So let's say we have one central point here, right? We have another central point here, right? Then let's say we have another central point over here. Okay. So what K-means is actually helping us to do over here is to be able to associate these, right? To be able to connect these points, right? Associate these points into this centroid, right? That's what K-means will actually help us to do, right? That's according to how closer they are to the centroid, right? So let's say these points are closer to this centroid, right? These points are closer to this centroid, right? These points are closer to this, and you can see that these points are closer to this one, so they will be associated to this, right? So in this way, right, in doing this way, right, it's actually grouping these points according to how similar they are with respect to the distance measures between these points, right? So that's what it's actually trying to do here, right? Associating these points to common centroid, right? So that's basically what the K-means will do. We will actually going to have a common centroid, right? We'll be having a centroid that according to the distances between each of the points, right? According to the distances between each of the points, they will be able to be associated to this centroid that we've been able to identify. All right, we will talk about how we are going to identify these centroids, right? We'll talk about how these centroids will be associated and how we are going to choose, the many centroids that we want, how we're going to do that. All right, we're going to talk about that in the next steps. So what we actually want to identify here is that when we talk about K-means, we find centroids and then we associate some points to the centroid according to how closer they are, according to their distance, right? Basically, that is how is it. Now let's see some demonstrations of this, right? Let me take you to the Jupyter notebook, right, and then see some demonstrations of this. All right, so I have this simple code here. Right, I have this simple code here that I'm going to run. We've not come to the lab session yet, so we are not going to go through the code, but I just want to do a demonstration for you to actually see how this KMeans is actually working, right? So before we talk about code and those kind of stuff, let's get an intuition behind what we are doing. All right, so let me just run this, right? So if I run this and then run this and then run this and then I run this, right, I'm going to have this being popped up for me, right? This window popped up for me, right? All right, this window is what this code will actually help me to plot. To display, right? So this is just a graphical user interface that I'm using this T-Kenta to actually do, right? So before we talk about code and stuff like that, let me actually give you a illustration of what K-means is actually all about over here. Now, this one is telling us to type the number of clusters that we want. So I put in some data, right? I just generated some random data over here, right? Which is data ranging from say 1 to 200, right? So I just generated some random integers over here, right? I'm using the rand int over here to generate some random integers in here, right? So that's what I have fed this with, right? That's what I have fed this with. So depending on the number of clusters that you give, is actually going to cluster these many data points, right, into the many clusters that you give. So let's say we want 5 clusters, right? Let me give 5 clusters, and then I'll press on the process KMeans. So if I do that, now you see what I have over here, right? You see what I have over here. Let me actually make this one big. Right now, you see what I have over here, right? Now you can see that I have these 1, 2, 3, 4, 5, right? I have these five clusters. You can see the colors that have been used to actually cluster these, right? You can see that I have one over here, right? Then I have another over here, right? You can see that I have another over here, right? These ones have also been clustered for me, right? Then I have these ones over here too. I have these ones which have also been clustered into one group. Okay. Then I have you can think of this one too. You can see that these ones are also being clustered into another group, right? Or being clustered into another group. And you can also think of this, right? You can also think of this one, right? Also in another group. So I said I want 5 clusters. I want 5 clusters, and that's why I have 1, I have 2, I have 3, I have 4, 5 clusters. Okay. So these are just random data points that I generated, and these random data points have been clustered into different groups for me. Okay. So let's change this. Let's change the number of clusters that we put here. So instead of 5, maybe let's put say 4, right? Let's put 4 and then run it and see. Now you see what we have over here. Right, if we put 4, you can see that now we have this. We have 1 cluster, we have 2 cluster. You see the centroids that we have. So we have 4 centroids, right? We have 4 centroids, and then if you want to trace the clusters that we have, you can see that we have 1 cluster somewhere here, right? We have this cluster, right? We have this one, and then we have this, right? We have this one. We have this one here. We have this one, then we have that one. Okay, so you can see that we have different centroids, and then these points have been associated with centroid, and you see how the color has also been used to distinguish between the various centroids. Okay, now let's change the centroid again, right? Let's say we don't want this 3 let's go to 3 and then see, right? Now if we do that, now you can see that we have 3, right? We have 3 centroids, right? You can see that we have 1, we have 2, we have 3 over here, right? We have 1, we have 2, then we have 3 over here. You see that? Now we have 3 centroids, right? Because we said the number of clusters that we wanted 3, so we have 3 clusters, right? So you can think of this, right? So if you choose your cluster or your K to be small, it means that you're going to have huge clusters, right? And if you choose your K to be huge, right, it means that you're going to have small clusters. So here, if you say that our K is 4, right? Our K here is 4, right? You see that if you consider this one, right, this one is smaller than this, right? It's smaller than that. And if you consider this one, the number of clusters that we've put in this one will be smaller than this, right? The same way, the number of points that will be here will be smaller than that, right? The same way, right? And if you consider this, you can see that the data points are still very small, right? The higher the centroid, right? You can see that the groups will be very small, right? The groups will be very small, all right? So if you want larger groups, then your K should be small, right? If you want larger groups, right? If you want larger groups, or larger clusters, right? If you want larger groups or larger clusters, then K should be small, right? K should be small. However, if you want small groups, right? If you want small groups, if you want small groups, right, or small clusters, then your K should be large, right? Your K, like for instance, if you want small groups, right? So these are small groups, right? Then your K should be large so that you have many centroids, which is actually going to give you small groups, right? But if you choose K to be small, you're going to have large groups, okay? Now, one thing that you need to actually take note of, right? One thing that you need to take note of is that if you choose K to be small, right? If you choose K to be very small, let's say in this case it was maybe 2 or 3, right? You can see that let's take this centroid as the mean of all these points, right? As the mean of all these points. Now, if you consider the variance, that's the distance between each of the points from the central mean, right? That's the distance between each of the points and then the central mean, right? So if we take the distance between each of the points and then the centroid, which is the mean of them divided by the number of them, right? If we consider this, right? If we consider all this, which will give you the within group variance, right? That one, that is going to be large, right? Your within group variance is going to be large if you have small groups, right? If you have small groups. However, if you have large groups, right, it means that if this one is here, right, this one is going to be very small, right? It's going to be very small. So let's have a simple demonstration of just that, right? Before we do that, right? We are actually going to see how we are going to choose the K, and that one will come in handy when we talk about this within group variance, right? We are going to talk about it in detail, but just to give you a little bit intuition about that, right? Just to give you a little bit intuition about that. All right, let me get rid of that. Okay, so let's see what I was talking about over there, right? So if we have say this, right, and then we have our data points in here. If we have our data points in here, right, and then I choose if I choose say one centroid, right? If I choose say one centroid, and if we consider this centroid as the mean of all these points, right? As the mean of all these points. So the within group variance is nothing but x, right? That's each of the points minus the central point right over here. And you find the square of that. You find the sum of all of that, right? That's we do it for all of these points, and then you find the sum of that, right? Divided by the total. The number of points that you have over there, right? So if we have just this one, it means that if you consider, say, the distance between this and then the point over here is actually going to be very large, right? It's going to be very large. However, if we have another centroid here, right? If we have another centroid, it means that, and then maybe another centroid here, right? It means that this point is going to be associated with this, and not that, right? This point is going to be associated with this, and this it will not be associated with this anymore, right? It's going to be associated with this. So you see that now the variance is going to be very less, right? The variance is going to be very less. As against when we were having only one centroid where we were having large variance, right? Now you can see that now the variance will reduce. So the larger the centroids, right? The larger the centroids, the less the within group variance. We are going to talk about this when we're talking about how we should choose our K, right? How we should choose our K, right? So just to give you an idea of how that thing works, right? We're going to talk about this, so don't worry about that. All right.